Theories of acid-base titrations. Theories of acid-base titrations provide a conceptual framework for understanding the chemical processes involved in these reactions. Two prominent theories that explain acid-base behavior are the Arrhenius theory and the Bronsted-Lowry theory. Each theory offers a different perspective on how acids and bases interact. Arrhenius theory 1. Proposed by Swedish chemist Svante Arrhenius in the late 19th century. Defines an acid as a substance that ionizes in water to produce hydrogen ions, H ions. Defines a base as a substance that ionizes in water to produce hydroxide ions, OH ions. According to this theory, acid-base reactions involve the transfer of H ions from acids to water and OH ions from bases to water. Examples of Arrhenius acids include hydrochloric acid, HCl, and sulfuric acid, H₂SO₄, which produce H ions when dissolved in water. Examples of Arrhenius bases include sodium hydroxide, NaOH, and potassium hydroxide, KOH, which produce OH ions in aqueous solutions. 2. Bronsted-Lowry theory. Proposed independently by Danish chemist Johannes Bronsted and English chemist Thomas Lowry in the early 20th century. Provides a more comprehensive and versatile definition of acids and bases compared to the Arrhenius theory. Defines an acid as a substance that donates a proton, H ion, to another substance, a base. Defines a base as a substance that accepts a proton, H ion, from another substance, an acid. In the Bronsted-Lowry theory, acid-base reactions involve the transfer of protons, H ions, from one molecule to another. This theory can explain a wider range of acid-base reactions, including those that do not involve water as a solvent. For example, in the reaction between ammonia, NH3, and hydrogen chloride, HCl, NH3 acts as a base by accepting a proton from HCl, forming ammonium ion, NH4, and chloride ion, Cl. 3. Lewis theory. Proposed by American chemist Gilbert N. Lewis in the early 20th century. Offers an even broader definition of acids and bases compared to the Bronsted-Lowry theory. Defines an acid as a substance that can accept an electron pair. A Lewis acid is an electron pair acceptor. Defines a base as a substance that can donate an electron pair. A Lewis base is an electron pair donor. The Lewis theory includes a wide range of reactions beyond proton transfer, making it applicable to reactions involving coordination compounds. Lewis acids like aluminum chloride, AlCl3, Lewis bases like ammonia, NH3. These theories provide different perspectives on acid-base behavior and are useful for understanding and predicting chemical reactions, including acid-base titrations. The choice of which theory to use depends on the specific context and the nature of the substances involved in the reaction. Enjoy some classes. We provide you with valuable and up-to-date knowledge about the pharmacy education. We create entertaining yet informative videos on topics such as chemistry of drugs, biochemical reaction, and much more. Hit that subscribe button and press the bell icon and join our mission to make understanding pharmacy easier for everyone. Like, share, and comment on our videos. We look forward to hearing from you.
Johnson Classes.
The best for best.